Welcome back. In this episode, we will discuss about the Euler totient function, or sometimes you can call it as a phi function also. This is treated as a phi of n. So, what is phi of n? Phi of n means the definition of Euler function is if I want to find out the Euler totient function that are to be relatively prime less than the n. Prime that are less than n. Okay, this is the first condition. Whatever the n you take, below the n, the numbers are relatively prime. Okay, so n may be prime or may be composite. Okay, so n may be prime or may be composite. Let us take n is equals to 5. What is phi? Phi of n. Okay, so phi of n means if you find the GCD of that n number, that means GCD of 1 comma n, you will get you need to get 1, right? So let us take phi of 5, which I have given 5 here. Phi of 5, how much? Okay, for this I need to calculate the GCD below the 5, that means less than 5. Okay, GCD 1 comma 5, that is both don't have the common factors. For 1 we have a 1, 5, 1 into 5, so only the common factor is 1. If you have a common factor is only 1, that is GCD 1 comma 5 equals to 1, that is relatively prime. Okay, relatively prime. Next, GCD 2 comma 5. Here also the common factor is only 1. Without remaining all the numbers are not correlated. And the GCD 3 comma 5 is also having only one factor, that is 1. GCD 4 comma 5, that is also a factor 1. So below the 5, 1, 2, 3, 4 all are having relative prime numbers. From this point you can understand that phi of 5 is equals to 4. So the formula is to find the phi of n for a prime can be calculated. So to find the phi of n for a prime can be calculated as phi of n is equals to n minus 1. Simple formula. So to find the phi of n, you need to use the formula n minus 1. So if you take another problem, phi of 7, simply directly you can write as 7 minus 1, which is nothing but a 6. Right? For this purpose, we can check as phi of 7 is equals to GCD 1 comma 7 is 1. Similarly, for a GCD 2 comma 7, G of 2 comma 7 is also 1. GCD 3 comma 7 is also 1. GCD 4 comma 7 is also 1. GCD 5 comma 7 is also 1. GCD 6 comma 7 is also 1. All are getting 1 below the 7, less than 7. How many here? 1, 2, 3, 4, 5, 6. So GCD is 5 of 7, which is nothing but 7 minus 1, 6. Directly I can get the answer. If I want to check the individual GCDs for each and every number below the 7 with the 7, then I'll get the same answer. Okay. So this is one scenario. Another case is also is there. Now I will see another case, that is case 2. If n is a prime, if n is a composite number, composite number, and and uh, and write as primes multiplication, write as in the form of prime multiplications. Then I can use this formula. So the formula is, in case n is equal to some 21. So phi of n is equals to phi of 21 can be written as 7 into 3. So 7 is a prime number which is treated as a p, and 3 is a prime number which is treated as a q. So in this case, what is the formula for the prime? Phi of n is equals to p minus 1 into q minus 1. You can write like this directly. So if n is a prime, also you can use this formula. So n is a prime, and write as prime multiplications, prime factors. Write as prime factors. Then p minus 1 into q minus 1. P minus 1 means this is p. P is equals to 7 here, and q is equals to 3 here. So 7 minus 1 into 3 minus 1. 7 minus 1 is 6, 3 minus 1 is 2. So 6 into 2, 12. So phi of 21 is equals to 12. Right? This is this is second case. In the same scenario, you can write as another case 3. I can write as case 3. For case 3, like 216, phi of 216, how much? So phi of 216 can be written as 2 power 3 into 3 power 3, I think. 2 power 3 is 8, 3 power 3 is 27. 27 into 8. 5, 7 is 56, 16 plus 5, 21, right? So this can be written as 2 power 3 into 3 power 3. So P is equals to here 2, Q is equals to 3. Okay. So for this, phi of n, you can write the formula as, for powers of primes numbers. Okay, powers of prime numbers. So in terms of powers లో వస్తే కనుక prime numbers కి ఇలాగ అప్లై చేయాలి. What is the formula? P is equals to phi of n is equals to n into 1 minus 1 by p1 into 1 minus 1 by p2, like that, up to n. So here n is equals to 216. So 1 minus, this is the p1 and this is the p2, if you write like that. 1 minus 1 by 2 into 1 minus 1 by 3. So here 216 into 1 minus 1 by 2 is 1 by 2 into 3 minus 1, 2 by 3. Okay. So this is 7 3 is 21, 3 2 is 22, and this is 2, 35, 36. So 36 into 2, 72. Okay. So phi of 216 is 72. So like that you can solve the problem. So what are the formulas so far we used here for finding the Euler totient function is, so we have 3 formulas for finding the Euler totient function. One of the formula is for the lowest values of n, phi of n is equal to n minus 1. For a small number of prime numbers, you can use the n minus 1. For a medium numbers which are like some p into q, or the primes, only primes. Okay, p into q, only primes, pq. So pq primes unte, then use the function as p minus 1 into q minus 1. And another function is phi of n which is large enough, then use the formula n into 1 minus 1 by p1 into 1 minus 1 by p2, like that. Okay, these are the three formulas you need to use for finding the phi of n for any value of n. Okay, which formula is suitable one to get the answer is, that is up to you. If n is a large enough and having the powers like 2 power 3 and 3 power 3, something like that, we have used this case 3. Only small powers 2 into 3, you can use this function. Only we have only one value of the prime number 3, 5, 7, something like that, we can use the first case. Like that, use the three cases to get the better answer. Finally, if you get benefited from this video, please share, like, subscribe and comment on this video for the next videos. Thank you very much. See you.